Dear students, I'm going to discuss with you the relationship between the central moment generating function and the cumulant generating function. इस सिलसिले में सबसे पहले let us consider exactly what do we mean by the central moment generating function. क्योंकि आमतौर पे हम जब MGF की बात करते हैं तो हम उस पर्टिकुलर MGF की बात कर रहे होते हैं जिससे वो वाले मोमेंट्स जनरेट होते हैं which are not the central moments but which are the moments about the origin or in other words the moments about zero. तो वो तो आप जानते ही हैं कि उसके लिए well known notation जो all over the world इस्तेमाल की जाती है that is capital M of t और अगर हम चाहें तो सबस्क्रिप्ट में x भी लिखेंगे if we want to indicate that the random variable that we are dealing with is x और उसकी जो definition है वो भी आप जानते हैं it is the expected value of e raised to tx. तो वो जो MGF है that is the well known one and that is not the central MGF. Central MGF की definition क्या है और notation क्या है? One of the notations that is used is capital C of t और इसमें भी अगर हम चाहें तो subscript में capital X लिख सकते हैं. So ना भी लिखें तो it's okay. So what do we have? We have capital C of t, the central moment generating function. And what is the definition of this one? Well, it's not difficult. It's quite simple. It is the expected value of e raised to t multiplied by x minus mu. जब हम MGF moment generating function वो वाला कंसिडर करते हैं जब moments about zero generate होने हों तो हम कहते हैं expected value of e raised to tx. इस पे जरा गौर कीजिए. ये जो हम कह रहे होते हैं expected value of e raised to tx तो क्या हम इसी को यूं नहीं कह सकते expected value of e raised to t multiplied by x minus 0. तो यहाँ क्या है expected value of e raised to t multiplied by x minus mu. इसलिए कि इस particular MGF से जो moments generate होने हैं they are the central moments और central moment किसको कहते हैं? The moments about the mean, the moments about mu. तो जो चीज आपको चाहिए वो t में से उसके मुताबिक subtract हो रहा है. It is as simple as this. All right, now that we are clear about the definition of the central moment generating function, let us deal with it in some detail. So, as you can now see on the screen, capital C of t is the expected value of e raised to t multiplied by x minus mu. So that can be written as the expected value of e raised to tx minus mu t. आप वो जो bracket है उसको खोल लें. And then you can write it as the expected value of e raised to tx multiplied by e raised to minus mu t. अब ये expectation जो है ये x के हिसाब से हो रही है. Therefore, e raised to minus mu t acts as a constant and it comes out and we have e raised to minus mu t multiplied by expected value of e raised to tx. In other words, e raised to minus mu t into mt. तो ये तो पहली रिलेशनशिप वो है जो सेंट्रल MGF को जो वेल नोन MGF है mt उसके साथ कनेक्ट कर रही. लेकिन जो मैं आपके सामने इस वक्त रखना चाहती हूँ वो है, as I said earlier, the relationship between the central MGF and the CGF, the cumulant generating function. So let's try to look at that. By definition, you know that the CGF, capital K of t, which sometimes, by the way, is denoted not by capital K of t, but by psi of t, where psi is a Greek letter, और कोई और notation भी इस्तेमाल हो सकती है, लेकिन you should know the various notations which are being used. इस वक्त फिल वक्त हम capital K of t ही से इसको denote करते हैं. So as I was saying, by definition, capital K of t is the logarithm of mt. तो अब अगर दोनों sides का आप e raised to the expression अगर करें, यानी exponential उसके साथ attach करें दोनों तरफ, then what do you have? You get e raised to kt equal to e raised to the logarithm of mt. लेकिन आप ये भी जानते हैं कि e raised to log of x or e raised to log of anything is equal to that thing. So therefore, e raised to log of mt is the same thing as mt. तो ये जो relationship, जो basic definition थी CGF की, कि capital K of t is equal to log of mt, उसी को हम rewrite कर सकते हैं इस तरह कि mt is equal to e raised to kt. अगर mt के बारे में हम ये बात हम कर सकते हैं, तो अभी थोड़ी देर पहले जो हमने बात की थी उस पे वापस जाते हैं. हमने कहा था कि capital C of t is equal to e raised to minus mu t into mt. तो अब हमने इस वक्त mt की जो वैल्यू निकाली है उसको वहां पुट कर देते हैं. So what do we have? We have capital C of t equal to e raised to kt into e raised to minus mu t. यानी मैं फिर रिपीट कर रही हूं कि mt की जगह पे we have now substituted e raised to kt. अब आप ये जो पावर्स हैं इनको ऐड कर लीजिए. So what do we have? e raised to kt minus mu t. Now what I have got just now, what is this? फिर देखिए, capital C of t, ये क्या चीज थी capital C of t, my dear students? It was the central moment generating function, central MGF. और अभी जिसके बराबर आया है वो क्या है? e raised to kt, capital K of t minus mu t. तो ये capital K of t क्या है? The cumulant generating function. So this is the relationship that we have been able to establish between the central MGF and the cumulant generating function, the CGF KT. All right, now that we have established this, after this, it is easy to understand कि अगर इनमें relationship है, तो फिर cumulants और moments में भी relationship होना चाहिए. क्योंकि ये cumulant generating function है KT और CT जो है वो moment generating function है, यानी वो वाला कि जो central moments generate करता है. तो फिर जाहिर है कि उनका भी तो आपस में ताल्लुक होना चाहिए ना. So, without going into too much derivation right now, that you can try yourself, and you should, I will present to you some of the main results that connect the central moments with cumulants. The results are as follows. Mu1 is equal to 0. The first moment about the mean is always equal to 0. यानी ये तो of course एक result वैसे ही है. उसके बाद जो हैं, they are the ones which give you the relationships. Mu2, which is the second central moment, or the second moment about the mean, or the variance of the distribution, that is equal to kappa 2, the second cumulant. Mu3, the third central moment, is equal to kappa 3, the third cumulant. Mu4 is kappa 4 plus 3 times kappa 2 square. So this is a polynomial in the cumulants, but please note that the highest cumulant is kappa 4. इधर mu 4 है तो उधर भी kappa 4 है, kappa 5 नहीं है या 6 नहीं है. इसके बाद देखिए mu 5, the fifth central moment, it can be derived and proved that it is equal to kappa 5 plus 10 times kappa 3 into kappa 2. इसी तरह एक और ले लेते हैं, mu 6, it can be proved that it is equal to kappa 6 plus 15 times kappa 4 into kappa 2 plus 10 times kappa 3 square plus 15 times kappa 2 cubed. ये जो पॉलिनोमियल है, अगेन इसमें भी और इससे पिछले वाले में भी आप नोट करें कि जो हाईएस्ट वो है क्यूमुलेंट, वो उसका नंबर वही है जो आपके सेंट्रल मोमेंट का नंबर है. Having said this, I also want to present to you the results in, let me say, the reverse order, that the cumulants being expressed in terms of the central moments. So what are the results? Well, obviously, if mu 2 is equal to kappa 2, then kappa 2 is equal to mu 2. Similarly, kappa 3 is equal to mu 3. However, kappa 4, it can be easily derived, is equal to mu 4 minus 3 times mu 2 square. Similarly, kappa 5 can be proved to be equal to mu 5 minus 10 times mu 3 into mu 2. And kappa 6 is mu 6 minus 15 times mu 4 into mu 2 minus 10 times mu 3 square plus 30 times mu 2 cube. So this is how we can see that moments, the central moments are related with the cumulants, and the central moment generating function is related with the cumulant generating function.